All right, this is chapter 11:1. We are starting our unit on irrational expressions and equations. We've touched on this, and if you've already memorized your perfect squares to 25, it should be pretty easy. Again, you're going to need them. So let's talk about a square root. Square root is when an operation yields a number, which, when multiplied by itself, produces the given number, meaning two numbers times itself equal, the root of 16 is what number times itself equals 16? 4. So it's 4. So 4 would be the root. And that's because 4 times 4 is 16. You don't need to write this page. You can just kind of listen. So if a is greater than or equal to 0 and a squared equals b, then we can say a is the square root of b, right? So if we have something like 0 squared, we can say that 0 squared equals 0, and then if I take the square root of 0, what do I get? 0. Okay, or 1 squared is 1, and if I take the square root of 1, it equals 1, right? 2 squared is 4, and the square root of 4 is? 2. 3 squared is 9, and the square root of 9 is? 3. Good. And so 4 squared and so on, you know. Are squares and roots inverses. So can we go the other way, right? If I take a number, I square it, then I root it, right? I get the same thing, right? Mm-hmm. You'd think. Try it again. Does it work with a negative number?
No.
If I take negative 3 and I square it, what do we get?
9.
Positive 9. But then when I take the root of 9, what do we get? 3. That's right. So it doesn't work with negative numbers. This only works with positive numbers. So, which brings us to start talking about some of the language. Every positive number has two roots. We call it a positive root and a negative root. Okay? The positive root's what we've been talking about, or you guys have been seeing for a while. We call this the principal square root. Okay? These, you do need to write this down and know the language right here, this portion. So we've got the positive square root, or we call it the principal square root, and we have the negative square root. And how we show that is with a negative on the outside of the radical. This little sign right here, this little sign here is what we call a radical. Okay? So if we have the negative outside, we would say that that's almost like saying negative 1. Negative 1 times the square root of 16. Negative 1 times 4. So negative 1 times 4 is negative 4. Does that make sense? When you have that negative, questions? So the root of negative square root of 16 is negative 4. That's how we show our negative roots. Questions? All right. The square root is not the inverse because it only gives the positive root. So if I were to take what times itself equals 100?
10.
Or
negative 10.
Negative 10. We have two solutions there, right? But what is the square root of 100?
10.
Only the principal root, 10, the positive one, right? So, simplify each root below and identify it as a positive root or a negative root. So what is number 1? Positive 7. And is it a positive root or a negative root?
Positive.
Good. Okay, number 2, raise your hand. Go, Elise.
The square root of 25 is 5, and then you multiply by negative 1, it's negative 5.
So it's negative 5 is the answer, and is it good? Okay, next. And then number 3. Yes. 12. Good. Number 4, please. Aton.
It's 4.
It's 4. And it's a? Good. Next one, Gracie.
-6, and it's a negative root.
Good.
Square root is 6, and you multiply by negative.
Fiona.
6 positive root.
Good. Number 7, Chloe.
It's 8, and it's negative root. -8.
-8, and it's a negative root. Good. And then the last one. Jamie?
No solution?
Yeah, well, there's no real solution. Because I've been telling you, remember when we talked about the real number system versus the imaginary number system? You've got all these, the naturals, the wholes, integers, rational. And then over here is the pi, the irrational. Together, these make up the real number system. But outside here, we have our imaginaries.
Well, how do you even do that?
When we see the square root of -1, we use the letter I. We assign it a variable for imaginaries. So that will come in Algebra 2. For our purposes, when we see the square root of the negative, we can't do it. It's not there's no real root. Okay? So that's exactly what we would say is not a real root. Yes?
For number 7, how is a -8? Does a -8 and -8?
Because there's a negative in front of it, hon. It's like -1 times what I just showed you a few minutes ago. It's -1 times 8. What does that equal to? -8. That's how we get the negative roots. We have to put the negative on the outside. Got it? It's the same, by the way, for number 2 and number 5. Okay? Okay. Estimating square roots. So, it's a couple different methods, and I'm going to show you both. The first time we do it, I want you to write this down, what I'm doing. We're not going to use a calculator tonight. I'm not going to have any way. Well, let's talk about the calculator issue later, after. So the square root of 21 falls between what perfect squares?
4 and 4.
Give me the numbers.
20 and 25.
Okay, so 16. I'm going to start at 16, and I want you to make a list. 20 is not a square.
Sorry, I was thinking
Okay.
it's 4 times
16, 7, the square root of 17. I want you to write this down. The square root of 18, the square root of 19, the square root of 20, the square root of 21, square root of 22, square root of 23, the square root of 24, and the square root of 25. And we are going to use our number sense and along with the benchmark of 1/2 to estimate this to the nearest tenth. I'm going to show you a way to get to the nearest tenth and a way to get to the nearest hundredth. And you need to practice both methods tonight. You're going to want to do mine because it's faster, but you need to do the other way because you may be given a question that says estimate to the nearest hundredth. Okay, so if I went exactly to the middle, I kind of like take my fingers and I go here and here, here and here, here and here, here and here, here and here. So this is the middle, right? So if that's the middle, what's the square root of 16?
4.
It's a 4. What's the square root of 25?
5.
So this right here, this point is exactly the middle, and so that would be about 4.5. So if I'm asking for the square root of 21, what would your estimate be? 4.5 is in the middle.
Oh, oof. So 4.6.
4.6, yeah. 4.6 is a better estimate. So what I'm looking for you guys, is that you can estimate within the ballpark. of a half. If you had said 4.4, I would have marked you wrong. But if you say 4.6 or 4.7, you're within the right area using your half benchmark, 1/2 benchmark. Does that make sense? All right, does anybody care to go to the hundreds place? What would your guess be to the hundreds place? Go for it. Doesn't have to.
4.55.
Okay, she's saying 4.55. All right, let's find out. 4.58. But 4.6 is 2/100ths off. Actually closer than when we estimated by to the hundredths place. But you should be able to get within 1/10 of your number by estimating this way. Okay? All right, whoa. Okay. So, square root of 7 falls between what perfect squares?
4.
So we've got the square root of 4, the square root of 5, square root of 6, square root of 7. Oh, I already did 7. Square root of 8 and the square root of 9. And the halfway mark would be right here, right? This is 2. This is 3. What's your best guess? The lower the numbers are, the harder it is to be. Okay, I say it's 2.6, but you guys can go. That's so close. You've got only three numbers in here, 2 numbers. So I'm going more. It's well beyond 2.5. So I'm guessing 2.6. Anybody else have another guess? 2.6, 2.7. Let's check it. 2.65. But the ones that are low are really hard to estimate. The bigger they get, so 32 falls between what? 25, 26, 27, 28, 29, 30, 31, oh my God, 32, 33, 34, 35, 36. Okay, so halfway would be, it's so hard to even do this here. 1, 2.
Between 30 and 29. Or 30 is like.
I get between 30 and 31. Am I wrong? 1, 2, 3, 4, 5, 6.
36.
3, 4, 5, 6. Yeah. It's between 30 and 31. So this is 5. And this is 6. And we're looking at 32. So what do you think the best guess is?
5.6.
5.6, 5.7. I'm going 5.7.
Oh my gosh.
Okay, so now let me show you an easier way. Shh. Okay, instead of writing all those out, so the square root of 32 falls between, what did you say? 25, and this is 36. You can see this is a distance of 7, and this is a distance of 4. So I don't have to write all those numbers out. I can use that. It's much closer. It's not halfway. It's beyond halfway. So I would likely guess 5.7. Do you understand? So I'm going to stop writing these numbers now, and we're going to make it go. We're going to try and do it without the numbers. The bigger the number is, the easier it is to estimate. The smaller that window, there's so much room for error. Okay, 56. Oh, whoops. Okay, wait. Let's. Square root of 56. 56 falls between what?
49, 64.
64. So this is 7. This is 8. This is 7 jumps away. This is 7.48. So is it more or less than 7.5?
More. Less.
So it's closer to what?
7 point.
So what are we going to go with?
7.4.
7.4. I like it. You guys understand? That's really the most of the work that you would have to do. 7.48. Okay, this should be an easy one. Square root of 99.
That was closest to 100.
It's 9.9. So 9.9. Okay, square root of 81.
9.
Okay, sorry, square root of 85.
9.3.
I'm going to say 9.2 because your distance, look, 85 falls between 81, 85, and 100. Look at the distance here is 15, and this is 4. So I'm going to say 9.2, maybe 9.2, 9.3. As long as you're within that ballpark, not ballpoint, I'm okay. If you had guessed 9.3, if you're guessing 9.4, that's pretty close to a half, and it's not. Do you understand? All right, so here's my warning to you. Tonight, when you're doing this, there's no way for me to know if you used a calculator or not. If you don't use a calculator, you won't get good at this, you won't get fast at it. If you use a calculator, you won't get good at it and you won't get fast at it. It will affect you for the rest of the chapter and likely the rest of the semester. So don't use a calculator because you can easily estimate these and you will get so fast and so good. People start sitting out there while I'm doing this that do it a different way and they're like, how'd you get that fast? It's not because I'm like this math whiz. It's just like I use this estimation pattern and you look how much faster you are at it now in the small amount of time we've done. So I want you to look at the number before, the number after. Is it closer to the number after? Is it closer to the other one? Use the halfway benchmark to estimate because you should be able to get within 1/10 of it. There is another way. I'm going to just... and let me show you. Okay, so 75, the square root of 75 falls between what perfect squares? 64 and 81. Okay, so the distance from here to here, this is the top, and this is the bottom. Okay, we know that this is 8, and this is 9. So it has to be 8 point something, right? And so the top, we say 75 minus 64. And the bottom is 81 minus 64. What does that simplify to? 81 and 9 over, and, right? Oh, no. No, sorry, you're right, 11. I'm wrong. 11 over what? 71 is 10 and 5, so over 15. Is that right? Okay, and then we can take that. This is, whoa. So I will accept a fraction too. And then if you have to get to the hundredths place, then you just divide the 15 into the, right? And we end up with, did I do my subtraction right? Yeah, 75 minus 64 is 11, and we have 81 minus 64 is 17. Oh, wow. That's 17, not 15. 17. Okay, and so I'm dividing 17. It goes, I don't know, 5 times, 4 times. 17. No. So it goes 6 times, right? 6 times 7 is 42. Carry the 4. 6, 7, 8, 9, 10. And I have 8. I bring down a 0. 17 goes about 4 times. So do you see how I can get closer? 81.64. It's about 81.64 or 11 over 17.
How can you do that?
Well, it's just another method. It's method number 2. You want to try it that way? Yes.
It would be
78.
8, not 81.
Oh yeah, you're right. It would be 9. No, it would be 8. This would be 8 and 8.64. So let me try that on the calculator. Second square root of 75 is 8.66. I got within 2/100ths. So
Divide by 11.
what?
4, you divided 4 by 11. On the top whenever you did one.
I didn't divide 4 by 11.
I mean 11.
11 by 17.
Oh.
Look, do you understand how I got the 11 and the 17? I get the 11 by subtracting these two. It always goes to the top. I get the denominator by subtracting those two, finding the difference. Then I divide 17 into 11. And I got 0.64. The true, if I estimate it, the true quantity, what time are we out here?
40.
Good, okay. The true amount is 8.66. Does that make sense? Let's try that method for finding the square root of 106. Let's try that method. Let's find the square root of 106. Let's try it once together. What comes before it?
100.
And 121. We know that this is 10 and this is 11. So we know it has to be 10 point something, right? Okay, let's first do it to the fraction. So how would I get the numerator?
106 minus 106 minus 100.
How do I get the denominator? Okay, and so we get 10 and this becomes 6 over 21. So I'm going to divide 21 into 6. It goes less than, it does not go 3 times, so I have to go 2. It's 42. I have 8, and that's 1. Okay, goes into 120 goes 9 times, so let's go 8 times. It's 8. So I could say it's about 10.28. I can go one more digit. It's 8, it's 16. The remainder is, that's 2, that's 1. Bring down, it goes how many times? 4, 5, 6, less than 6, 5. And it's 105. So we could say, we could round it to 10.229 or 10.28. Okay? And remember, you're always using the about sign. Now, I'm doing it on here. And it's 106. 10.295. Exactly what I got up here. Well, close to. Not exact. 10.295. So, do you understand that method? Which method do you guys like better? Let's say estimating method. Show me hands. Which people like the exact method where you get the exact numerator and denominator? And what I think is, you did it with Cacciatore?
Yeah.
I think that you should practice both ways. Because you'll get fast at mine and numbers. Sometimes they'll ask you questions where you need to estimate to the 100th place. All right, so now it says round to the nearest 100th when necessary. So what would number 1 be? 11. Negative 400 is about, or is it exact? Should be exact. You should know this one. Negative 20. Good. Next one, number 3, 71. Square root of 71 falls between
64 and 81.
64 and 81. Is it closer to 64 or the 81?
64.
So what are you estimating at?
8.3.
8.3? Let's see. I'd say maybe that's pretty close. Okay, what does it mean when you have the plus or minus sign right there? Positive or negative. And it's positive or negative 9. Does that make sense? Well, because they have a positive sign, this means positive and this means negative. So that means plus or minus 9. Positive 9 or negative 9. And when we estimate 18, oh, I shouldn't write that. We got to do this. It's between 16 and 25, so it's about 4.2. So it's about 4.2. 4.2, 4.3. Okay. Next one. It says 2 plus or minus the square root of 99. What is the square root of 99 estimated to be?
9.9.
Now that's an easy one. Like I would never do the long method. This means 2 plus 9.9 and 2 minus 9 and 9/10. All right, so now let's check 121 is 11. So we're going to evaluate negative 400. What do you guys guess? Negative square root of 400? Negative 20. Negative 7, the square root of 71 falls between 64 and 81. What is it closer to? Okay, so that's about 8 point what? What is your best guess? Is it 8.2, 8.3, 8.4? Good. Within that boundary, square root of 81. Notice the little plus or minus. What does that mean, Nicole? Huh? It's both positive and negative 9. Good. As soon as we start estimating, 18 is about, falls between 16 and 25, 4.2. So positive 4.2 or negative. And notice the sign is about. You got to use that. 9.9 is about, 99 is about 9.9. So now we have 2 plus or minus 9.9. So that means 2 plus 9 and 9/10, or 2 minus 9 and 9/10. Okay, questions? And then that makes 2 plus 9.9 is 11.9, and 2 minus 9.95 makes, so this becomes 11 and 9/10, and this becomes 7 and 9/10. And if you look at it with the calculator, we're pretty close. It was 0.95. Okay, perfect squares. Let's get this. Everything that falls between those perfect squares, like these are rational roots, square root of 4, square root of 9, square root of 16. But what falls between the square root of 9 and 16 is what we call an irrational root. So the square root of 9 is rational, but the square root of 10, irrational. Square root of 11, irrational. Square root of 12, what's the next rational root?
16.
Yep. You get the idea? Okay. So let's identify our rational versus irrational roots. Okay. Not yet. I think that our rational roots are all perfect squares. Okay, sorry. Okay, number 1. Let's go with Brianna. Brianne, is it rational or irrational?
Irrational.
Good. Number 2, go, Jamie.
Rational.
Good. Number 3, Chloe.
Irrational.
Good. Next one, number 4, Maddie.
Rational.
Good. Negative 7 is rational. Number 5, Isabella.
Irrational.
Okay, next one, Tony.
Irrational.
Good. Number 7, Max.
Irrational.
Good. Number 8. Did you say irrational?
Irrational.
Okay. Number 8. Go, Eitan.
Irrational.
Good. Number 9, Harrison.
Irrational.
Good. And number 10, Daisy.
Rational.
Good. You get the idea? Well, we can keep going. Let's go. Rational, irrational. Elise.
Rational.
Good. Go. Mike, what?
Rational.
Grant.
Irrational.
Okay. Noah.
Rational.
Okay. And we've got Gracie.
Irrational.
Good. And we have Fionn.
Irrational.
And next is Nicole.
Irrational.
Good. Did you say 0 is irrational? 0 is a perfect square, so it's rational. 0 and 1 are both perfect squares. Number 8, go, Brienne.
Rational.
Good. And then number 9,
Irrational.
good. And number 10.
Oh, irrational.
What do we say?
Not real. Not real.
It's no real roots. There are no real roots. It's neither because it's not a real root. All right. Now, another way they ask this is for you to determine what consecutive integers each root lies between. I want you to practice that too because all these ways of estimating come up. So the square root of 7 falls between what perfect squares?
2 and 9.
4
4.
and 9. So this would be, it falls between what consecutive integers? 2 and 3. Okay? Square root of 20 falls between what perfect squares? And so it falls between what two integers? Good. 85 falls between 9 and 10. And 45 falls between? Good. Do you get the idea? So that's pretty easy. You're just finding the perfect squares before and after. And then our last problem, it's estimating the irrational without using the calculator. It's basically going back to my first method I taught you. So you've learned 3 methods, how to estimate between 2 integers. You've learned how to estimate to the nearest tenth without a calculator, and you've learned how to do it with the fraction method. So if I have something like this, finding the side of a square, we can set it up as a equals side squared, right? And then we can substitute what we know. The area is 49, so what would the side measurement be? 7. We know it could be 7 or negative 7, but measurement can't be negative. So that gets kind of kicked out. So the square root of 49 is 7. But what happens when we're given something like this? Can we estimate it? What is the square root of 40? What does it fall between? 36 and 49. Is it closer to 36 or is it closer to 49? Okay. In fact, I almost might write it's the square root of 36, the square root of 40, the square root of 49. This is 9 digits. This is 4 digits. What's your best estimate? 6.2, 6.3, I would go with. Good. Let's see. It's about 6.3. There you go. And that is our lesson for the day. I'm going to go through one more time. I want to go through one more time trying to do the fraction method because I can't remember if I recorded it. If I did record it, then you don't need to listen to this. If I didn't, let's just add it in. So let's give me a number, any number between 1 and 200. Let's go in the hundreds. 173. Okay, let's go 173. The square root of 173. So the square root of 173 falls between what perfect squares? You don't know your perfect squares. It would be 169,
Which is 13
and that's 13. And then this would be 14 is 196. Okay? So, we know that the answer has to be 13. And remember, this is the numerator. This is the top. And this is the bottom. Fine. So we find a difference between the top, 173 minus 169, and the bottom is 196 minus 169. And what does that simplify to? 173 minus 169 is 4 over what? Yeah. So, if that's the case, I can make it go even closer by 27, not 24. 27. So I'm going to put 27 into 4. Right? My decimal's here. It goes how many times? Once. 27. The remainder is 13. Bring down a 0. 27. 30 goes into 13. How many? 3 goes into 13 about 4 times. Let's try 4. 4 times 7 is 28. Carry the 2. That's 8, 9, 10. Can I fit another? Yep, that'll work. So 10 minus 8 is 2. That becomes 2. And bring down another. So it's about 13. Let's go one more time. 30 goes into this, or let's go 5, 6, 7. Okay, let's try 7. Times 7 is 49. Carry the 4. It's set 14, and 4 is 18. Can I fit another 27 in there? I can. Right? So it's 8. So it's an 8. So if I were going to estimate this to the nearest hundredth, I could say it's about 13 point and 15 hundredths. Okay, so if I do it on the calculator, second, 173, it comes to 13.152. So we're pretty close when we go this way. One more time. The way we get this is we go from low to high, and this is the middle minus the top, and this is the bottom minus the top. Do you guys understand this method? Mm-hmm. Nicole, do you? Because I don't think you had it last year, right? Do you understand it? This helps when you're doing really big numbers in the thousands. You might want something a little bit more exact. You have a method to really get to that tenth. But I still use my estimation method, so both are good.